Jai Hind all. Myself Amita Asthana from Ajay Kumar Garg Engineering College, Ghaziabad. Myself working as assistant professor in EC department. Now in today's lecture we are going to discuss one very important topic from unit 4, that is Eigen Functions. So we will understand in this lecture what are Eigen Functions, and one more concept we will see, that is Eigen Values. So how we calculate the Eigen Values as well as the Eigen Functions. So let us consider one LTI system. Any LTI system whose impulse response, as I can say, that is ht. The input I am giving to this particular LTI system as xt, and the output being yt. So since we are discussing the Eigen Functions, so what are these? So here we need to understand that whenever we give some input to my LTI system, this is linear time invariant system. As linear, that means that property which satisfy the homogeneity and additivity, and time invariance where there is a shift in the input and it just also shifts the output, then it is called the linear time invariant system. So here what we can say that let's say we are giving some input and my yt comes out to be some constant lambda, and this is going to be multiplied by input. The concept is that lambda is a constant and xt is the input, and I can say my output is equal to some constant multiplied by the xt, or I can say the input term. So whenever the output comes in this form, so we define Eigen Values and Eigen Functions like yt is equal to lambda xt, output is some constant multiplied by input, then I say lambda is my Eigen Value. Lambda is my Eigen Value and xt is known as Eigen Function. So here that lambda is EV and xt is EF. So very simple concept in terms of LTI system. The Eigen Value is nothing but the constant which is going to be multiplied by the input, and the input is now said as Eigen Function. So suppose I am having one input e raised to the power 8t. This is my input, and by passing through the LTI system, the response comes out to be comes out to be 1 by 5 multiplied by e raised to the power 8t. So if 1 by 5 into e raised to the power 8t, that means what are the Eigen Values and what are the Eigen Function here? So very easily we can tell the Eigen Value, the EV is 1 by 5 here, and Eigen Function is e raised to the power 8t. And why I am defining here the Eigen Functions and Eigen Values? Because This term is my input, as I can see. This term is my input and this is my constant, and output is some constant multiplied by input. So e raised to the power 8t becomes my eigen function and 1 by 5 becomes my eigen value. So by having this particular concept, we will understand how we do the numerical and how the questions are asked in your examination. So we have any LTI system, and by using the convolution formula, here it is my convolution formula, I can calculate the output for any input whenever the impulse response of the system is known. So the yt is nothing but xt convolution of ht, and that is equal to minus infinity to infinity xt minus tau h tau d tau, or we can also say that convolution, the output of the LTI system, is equal to minus infinity to plus infinity x tau ht minus tau d tau. Both ways we can calculate the convolution, whether I want to shift my xt input, whether I want to shift my ht, the impulse response of the system. So this is how we represent the convolution or the response of the LTI system for calculating the output for the given input xt. Suppose we give input xt is equal to e raised to the power st. So in this formula, I would like to write this particular calculation. So here, for this particular input, when ht is known, I will write yt is equal to minus infinity to plus infinity xt minus tau, that means e s. In place of t, I will just put t minus tau h tau d tau. Okay. So this particular term I can break as e raised to the power st and multiplied by e raised to the power minus of s tau and h tau d tau. Okay. So now let us calculate the response yt. So here we have this term as we have written like this, and now I will open this exponential. This comes out to be e raised to the power st. Now since we are doing integration in terms of tau, so I can take this e raised to the power st as common. Okay, so e raised to the power st I have taken as a common, and in the integration what I am getting is minus infinity to plus infinity e raised to the power minus s tau h tau d tau. Now what is this? Clearly I can say this is nothing but the Laplace transform of the h tau. Why? I tell you. See how I write like this. So if I want to calculate the hs, okay, so what is the formula for hs is minus infinity to plus infinity. Okay, that will be h of t e raised to the power minus s t dt. This is how I calculate the Laplace transform for any, for any ht or whatever, any h tau. So here this I can replace like this, that is hs yt is equal to e raised to the power st into hs. Now coming to the output, that is yt is equal to hs e raised to the power st. So here my output is yt this is my constant, this is my constant, and input is e raised to the power st, because earlier I said my input is e raised to the power st and now my output comes out to be hs into e raised to the power st. This is a very important concept, and hence I can conclude that this is my EV and this is my EF. So input is multiplied by some eigenvalue and that is defined as Hs. Now to understand how we can apply this in our numericals. So this is clear. Let's suppose we are given some numerical and in which the output is given as 1 by 5 into e raised to the power 8t and input is given as xt is equal to e raised to the power 8t. So whenever we see any output given in terms of some constant multiplied by some input, then we should apply the concept of eigenvalue and eigenfunction. And the questions may ask to tell the eigenvalue for this particular question and they can ask for the eigenfunction. So here the Hs is equal to 1 by 5, okay, this is 1 by 5 and this comes out to be EV, okay. And one more thing, that here we can also, please note it down, this is very important point, this is very important, that S is equal to 8. Immediately by looking at the e raised to the power 8t multiplied by 1 by 5 and output is given like that, then Hs, the eigenvalue, this is my eigenvalue, that is Hs is equal to 1 by 5 and instantly we can predict that my S is equal to 8. This is how we do, like, because this is input, right, this is input and this is in the form of e raised to the power st. So if I compare, then immediately I can get the value of S to be 8, okay. By all these concepts we can have one numerical based on this particular. So here it is given one causal LTI system. The causal LTI system, that means wherever the output is a function of the present input as well as the past inputs, but not at the future inputs. So this will be the causal system. So any causal LTI system, the impulse response is given ht, right, and it is satisfying the following properties. Now look at the properties. When we look at the properties, when the system has input xt is equal to e raised to the power 2t, see here S is equal to 2, okay, and my output is given as yt is equal to some constant, here it is constant, and this is my input, because this is input and input is getting multiplied by some constant and hence producing the output. So I can readily apply the concept of eigenvalue and eigenfunction. So here my eigenvalue come out to be 1 by 6 and S is equal to 2. So here I can really write here that EV is equal to 1 by 6 and S is equal to 2, okay. So this is one important point, that from the first statement I can predict the value of eigenvalue and S. Now let us see the second property. The system satisfies the differential equation. and that differential equation is d by dt ht plus 2ht is equal to e raised to the power minus 4t plus a is some constant here, which whose values is not given here, ut. Now they are asking for the impulse response, that the question wants to calculate the ht impulse response for the given system which satisfies the properties of eigenvalue eigenfunctions and which is also satisfying this particular differential equation. So these are two important statements given in the question, and by using these two important questions we can find out the impulse response for the given LTI system. Now, so here we have few important conclusion, that EV is equal to 1 by 6 of course, and the S is equal to 2, and now I will write the differential equation so that I can solve this particular differential equation using these all values. So here this I will write d by dt ht plus 2ht is equal to e raised to the power minus 4t plus a u t, right? So here now taking the Laplace transform, as we have the value of s is equal to 2 using the eigenvalue function property. So I will take the Laplace transform, taking Laplace transform we will proceed the Laplace transform for this one, that will be s of hs plus, since initial values are not given so we are not going to consider. So here that is 2hs is equal to the Laplace transform for e raised to the power minus 4t will be 1 upon s plus 4. So that will be 1 upon s plus 4 obviously, and plus a upon s. So here hs s plus 2 is equal to 1 upon s plus 4 plus a upon s, like that. So here are the values, and we have solved the differential equation in that way. So we have reached up to this point, all the things we are having. So by putting the value of hs, okay, by putting the values of hs and by putting the values of s is equal to 2, as we have already calculated here. See, s is equal to 2 and hs we are having, see this hs as stated here, this constant, the eigenvalue is 1 upon 5, just like here I have taken this eigenvalue as 1 upon 5. In the question we can say that eigenvalue, that is 1 by 6. So I will write all these terms in my differential equation so that I can, my aim is to find out the value of a. So this is what we want to find out. So here I will write the value of hs, okay, and then I will write the value of s in the given equation. So I will write that is 2 upon 6 plus 1 upon 3 is equal to 1 upon 6 plus a upon 2, and hence I can solve for a. By solving this equation we can get this a is equal to 1. So up to this point we have reached, and what properties we are using here? The concept of eigenvalue and eigenfunction. We could apply the properties for EV and EF because the output which has been given in the question, that is coming out to be in the form of some constant multiplied by input. So we should be very aware whenever the question is given, we should be very careful to see whether the output is some constant multiplied input is, then we can apply the same concept to solve the question. Otherwise we won't be able to solve the question and we cannot proceed for the solution. Now we can put the value of A in the given differential equation. Since we are interested to find out, the value of HT, my aim is to find out the value of HT or value of HS. So now my A constant is 1 and I will rewrite my differential equation in this particular form, and taking the Laplace transform we can have HS is equal to 2s into s plus 4, 2 upon s into s plus 4. So what should be the next step? The next step would be we can find out the inverse, taking the inverse Laplace transform, and we can also calculate the HT. So here we will just do the partial fraction for this particular term, 2 upon s into s plus 4. We will apply the partial fraction, right, and this comes out to be 1 upon s minus 1 upon s plus 4, 1 upon 2 outside. So after finding out the partial fraction, I will take the impulse response, I will calculate the impulse response taking inverse Laplace transform. So what here I am doing is I am calculating or applying the formula for inverse Laplace transform. So 1 upon 2 will be same like this. For 1 upon s, that is nothing but ut. The inverse Laplace for 1 upon s will be ut, and for the 1 upon s plus 4, the inverse Laplace transform will be e raised to the power minus 4t. Please remember that whenever here it is plus, we take a minus sign here, and e raised to the power minus 4t ut. And hence we could calculate the impulse response, the HT, which has been asked in the question. The impulse response, and here is my answer for the given question. So only by applying the concept of EV and EF, we can calculate and we can solve the solution for differential equation. Maybe questions may be asked in some another form also, but that is also important, that we should know where to apply the eigenvalue and eigenfunction. I will again repeat, whenever the output is some constant multiplied by input, we can apply the EV and EF concept. Thank you.